All right, let's get started with 6.6. Last section we're going to do here in Chapter 6, Fundamental Theorem of Algebra. This is a short one, but an important one. So we've got one job and one job only: to use the Fundamental Theorem of Algebra in solving polynomial equations with complex roots. So that's the only new vocab, Fundamental Theorem of Algebra. What is that? We'll find out in a second, but first the skills check. Find the degree. Number one, the degree on number one is find the biggest power. The degree is 2. And then number 4, you can do 2 and 3. For number 4, let's use the quadratic here. Negative 0. B is 0 here because this is x squared plus 0x plus 16. Plus or minus square root of 0 squared minus 4ac all over 2a. And we've got 0 plus or minus the square root of negative 64 all over 2. So that's plus or minus 8i, I because of the negative, all over 2. So plus or minus 4i. Right? Square roots of negatives, we get imaginaries. So practice your quadratic on 5 and 6. Pause the video. When you're ready to go, we're moving on. All right, so I'm going to read this through and we'll explain the fundamental theorem of algebra. So we've solved polynomial equations, so x to the third or x to the fourth, right? Long equations, and found that the roots, the solutions, the zeros, are included in the set of complex numbers. So that being said is that the roots are either integers, they're rational, they're irrational, or they're imaginary. Okay? But can all polynomial equations be solved using complex numbers? And thanks to our good friend Carl Friedrich Gauss, in 1799, he proved the answer to this is yes. We're not going to go over the proof, but the answer that he came up with is so important that we get to call it the fundamental theorem of algebra. And then there's a corollary to that as well, which we're going to look at right here. So the theorem: if some polynomial has degree bigger than or equal to 1, so it's at least x to the first, maybe it's x squared or x cubed, but at least x to the first, and it has complex coefficients, then the polynomial equals 0 has at least one complex root. Here's the important part that we're going to use, the corollary. Okay, adding up all the imaginary and multiple roots, an nth degree polynomial has exactly n roots. So if you're x cubed, you have 3 roots. Now maybe some of them are imaginary, some of them are irrational, but you're going to have exactly 3. Okay? And so we also will have, in that example, 3 zeros, n zeros. All right, so here's the key thing here, is that we can figure out all the complex roots, the real roots and the rational roots, because we know the degree. So in example 1, the degree is 3. Now, let's start with the imaginary roots, complex roots. All right, so complex roots, because of conjugates, there's either going to be 0 or 2 complex roots. Because remember, if you have I, you also have negative I. Or if you have 3 plus 2i, you also have 3 minus 2i. So remember that the complex always comes in conjugate pairs. So it's either going to be 0 or it's going to be 2. Can't be 4 because the most roots we could have would be 3. All right, so that being said, and since we have to sum up to 3, we either have 3 or 1, because these two things have to add up to 3, real roots. So we add up the imaginary and the real, and we get the total number of roots. All right, what are the possible rational roots? Remember that we're going to do p over q, factors of 6, which are 1, 2, 3, and 6, over the factors of 1, which is just 1. So the possible rational roots are plus or minus 1, 2, 3, or 6, because if you divide by 1, it doesn't change your answer. All right, so those are the steps. There's only 2 examples here. This is the first one. See if you can figure out all the complex, the possible complex, possible real, and the possible rational roots for this polynomial. All right, and the second and last example for 6, is we're going to actually find all of the zeros. So the book doesn't include this step, but I'm going to throw this in there as a little bit of a help step. Okay, and in pre-calculus, we're going to do this as well. So here's what I want you to do. Throw this equation into your graphing calculator. X cubed plus x squared minus x plus 2. I'm going to check my window. It looks okay. I'm going to go ahead and graph it. All right, so it looks like we have one real root. I'm going to find what that is by calculating my zeros, which is number 2. And so my left bound, I'm going to go a little bit to the left. My right bound, and then my guess. And it says -2. All right? So now here's what we have to do. We have to make sure that -2 does work from the possibles. So when we come back here, first I'm gonna write out some steps. Step 1, find the possible rational roots. All right, so it's going to be the factors of 2 over the factors of 1. So 1 and 2 over 1. So it's either plus or minus 1 or plus or minus 2. And we said -2. So that is a possible one. We're going to take that. 2. Synthetic division. Using the root we found. All right, so let's go ahead and do synthetic. We've got 1, 1, -1, and 2. And our root on the outside is -2. Here we go. 1, -2. That's a -1. So that's a 2, that's a 1, and that's a -2. It does come out evenly. So that's going to be x squared minus x plus 1. Okay. The last step is once we're at x squared, which we are here, factor, and you might have to use the quadratic to finish. So let's go ahead and do that. And in this case, we do have to use the quadratic. There's nothing that multiplies to 1 and adds to -1. So our quadratic, -b plus or minus square root of b squared minus 4 ac all over 2a, which is 1. And so we've got 1 plus or minus the square root of 1 minus 4 is -3 all over 2. And so we've got 1 plus or minus I root 3 over 2. Pull the negative out. So look at that. We've got 1, 2 imaginary, and there's our third root, and we should have 3. So we found all 3 of the roots, all of the zeros. All right, those are your steps. You've got one problem to do. All right, and this kind of goes backwards. Explain how you could use the calculator to verify the zeros. You're going to do that first. Find your first zero using the calculator, synthetic, and then quadratic. All right, good luck with that. We'll go over the answers to this in class. Any questions, make sure we talk about it then. Good luck.